Hey, welcome. Today we're going to answer everything that you need to know about the AFRM kit, or Air Fuel Ratio Monitor kit. This is generation 2. The first generation was known as the AFX kit. Again, this is AFRM, or Air Fuel Ratio Monitor. So one of the first questions that we commonly get on the tech line is what exactly comes with the kit? What's in the box? Well, as we go ahead and open this thing up, first of all, you get your instruction sheet. And then from there, you end up with this little module here that has a connector on the back, a little button on the front. This is what's going to be displaying your air-fuel ratio. There is a small little piece of Velcro in here. This is so you can go ahead and attach your little module there to your dash or something. It comes with the wideband air-fuel ratio sensor right here. It comes with the exhaust boss that you got to go ahead and weld in, and a cap. And then of course it comes with the wiring harness to connect this all up. So one of the biggest questions is, what is this for? Why do we have this kit in our product line? What is it used for? Well, this is really just a tool to measure real-time air-fuel ratio, but this is intended to be on vehicles that didn't necessarily come with an air-fuel ratio sensor. So if we're talking like old school carbureted engines, or maybe even some newer fuel-injected engines that didn't have a way to monitor real-time air-fuel ratio, that's what this kit is for. It's a standalone kit that you can go ahead and install on any vehicle that'll accurately read gasoline engine's air-fuel ratio from 9:1 on the rich side up to 20:1 for an air-fuel ratio. This is going to be used mostly by engine tuners or performance industry type of people. We're looking to get that engine dialed in perfectly for the proper air-fuel ratio under different conditions. So it's really helpful for carbureted engines because you're no longer going off of feel or the way that the car reacts. You're actually able to get this thing dialed in perfectly using this kit. So here's what it's going to look like when you hook it all up. You're going to have your sensor. That sensor is going to plug into the wiring harness. That harness is going to have to be hooked up to power and ground. It also has two outputs there. We have signal ground and then a analog voltage signal that's output from this thing that you're able to hook up to maybe a meter or a gauge, something like that. And then we have our little control module that would go somewhere inside of the vehicle. So when this thing's installed, it needs power and ground, and that power and ground has to be somewhere between 12 to 16 volts. If this thing drops below 12 volts, it'll reset itself. So we need to make sure that we have good battery positive connection. So this air-fuel ratio sensor has to be hot in order to function. This heater is going to take about 3 amps or so on initial startup to get that heater up to temperature. And then after about a minute or so, it'll drop down to about 1.5 amps of consistent draw, because unlike a standard oxygen sensor, an air-fuel ratio sensor needs to be heated all the time in order for it to function. A lot of standard O2 sensors really just need that heater to get it working, and then it'll continue to work. This needs to be constantly running in order for the AFRM to work properly. Now, the best location for hooking up power and ground to this entire unit is going to be somewhere by the vehicle battery. Now, you can go ahead and run it through a relay if you'd like, but you want to make sure that you put a fuse in this system somewhere. You want to always fuse anything that you're hooking up to the vehicle battery. It's just offering protection for the vehicle. If you want, these wires are pretty long right out of the box, but if for some reason that you need a longer wire harness, you are able to go ahead and splice into these and make it longer. Just make sure when you do it, you use the appropriate gauge. So whatever gauge this would be, make sure you're using that gauge wire, and then you use some sort of solid connection. So either soldering the connection or maybe a heat shrinkable crimp connector, something like that, that's giving you a good long-lasting connection. Please don't just twist the wires together and put some electrical tape over the top. That's not a good long-lasting connection. It's going to give you accurate readings through the life of this unit. Now, this sensor here, the air-fuel ratio sensor itself, can be used full-time, like most modern vehicles use a full-time air-fuel ratio sensor, or you can use it just for tuning operations. That's why the sensor boss, which we're going to talk about in a second, comes with a plug. So after you're done tuning the vehicle, you have it dialed in where it needs to be, you can go ahead and install the plug in that hole, put the sensor back in the box, and wait until the next time that you want to tune this thing. You have that ability with this unit. The sensor will last a lot longer if it's not being in those harsh race conditions or performance conditions its entire life. So where do you need to install this sensor? You have to install it between 12 and 48 inches away from the engine. You need to make sure that you're upstream of the cat if it has cats, and you need to make sure you're upstream of your secondary air injection ports, because both of those will skew the reading that this sensor gets. If you install the sensor too close to the engine itself, you could end up melting down the wiring harness or something like that. If you're too far away, you can end up with condensation in the sensor, which will dramatically shorten its life. If this is a turbocharged application, you want to make sure that you're at least 18 inches from the engine. So just back it off an additional 6 inches from where you might have been before. And as with any sort of exhaust monitoring on a stock vehicle or performance vehicle, you need to make sure that you don't have any exhaust leaks. Those exhaust leaks can allow free air or fresh air to get into the exhaust and skew the reading that your sensor's outputting to the module. So like I said, we have a sensor boss. This thing needs to be installed on our exhaust pipe. This is going to prevent condensation from entering or puddling inside of the sensor. This boss does need to be welded into the exhaust pipe, okay? There's no way to thread this thing in or anything like that. It does need to be welded in. After you're done with welding, it's always a good idea to run a tap or thread chaser through this sensor boss just to make sure that you don't have any welding slag or anything inside of there so you don't damage the threads of the sensor. On the first install, the sensor will have anti-seize pre-applied. If you're removing that and putting it back in type of thing, go ahead and just take a little dab of copper anti-seize on those threads to make sure that you don't end up with that thing being bound into there or corroded in place. The torque value on this sensor is 45 to 55 Newton meters, so make sure you're torquing this thing. You don't want it to be loose, because then you could allow fresh air in there, and it would also potentially allow it to vibrate and crack or damage the sensor. And then lastly, just a quick note, the AFRM controller itself is not waterproof. So this little module, you're going to want to put this somewhere inside of the car. The harness is plenty long to run it into the car. You don't want this under the hood because it will get damaged with water. So here is that module. Here you can see the display on there. It's a digital display output. 14.57 right there is just an example of a stoichiometric mixture on a gasoline engine. The mode button on there is going to be used to change the operation, change the range, or set calibration. So if you press the mode button, that'll change your mode. If you hold it down, that'll give you free air calibration. You're going to adjust this range setting to adjust the analog voltage output. So if you're reading something other than gasoline and you're using the analog voltage output, you're going to want to change it from its default mode of 16 up to a leaner 20 to 1 analog range, depending on what kind of fuel you're working with. So when exactly do you need to perform the calibration? It's really impossible to know exactly when it should happen, but if you use these guidelines, it'll give you a good example or a good timeline of when to do it. If you're installing a new sensor, a new air-fuel ratio sensor, you're going to want to calibrate every time. Every time you put a new sensor into the system, calibrate it. Every time you change 3,000 feet, either up or down, go ahead and calibrate this unit. If you are tuning race engines or working with race cars in general, every time you tune the car, you're going to want to calibrate this thing beforehand just to make sure you get the most accurate response out of the system. And then if you're using leaded fuel in your car, you're going to want to calibrate this unit every hour because leaded fuel will significantly degrade this AFR sensor's ability to properly read. So once an hour with leaded fuel. How do you make this calibration happen? Well, first of all, we got to take the sensor itself out of the exhaust system. This gives us the best access to fresh air, gives us our best possible calibration. We're going to connect everything together and then we're going to go ahead and we're going to power up the system for 60 seconds. This allows the sensor to get up to temperature and then we're going to go ahead and turn the system off. Then we're going to power it up again and we're going to press and hold that button for 3 seconds and then we should end up with a countdown and it should read the display reading CAL or calibration. Afterwards, it should read CONP. This tells us that the free air calibration was completed. If we get a fault of any kind, make sure, first of all, that your battery voltage stayed high enough the entire time. That 12-volt mark is critical for performing the calibration. We have to stay above that mark on our vehicle. So earlier I mentioned that this thing is compatible with other fuels. Just know that this thing is meant to work with other fuels, but it's intended to display on a gasoline scale. So what I'm saying is, it's going to display 14.7 to 1 as stoichiometric on a gasoline engine. But that's not exactly true for a methanol engine or an E85 running engine or a diesel fuel running engine for that matter. We may need to go ahead and calculate out lambda to figure out what exactly it is that we're reading. And that's where those those voltage outputs really come in handy on here. So here you can see just an example of calculating for methanol air-fuel ratio. You're going to take that voltage value output and multiply it by 0.62 and add 3.96 to it. That's going to be on the default setting. If we go on the selectable AF20 setting, you'll have to just change up that math a little bit. But we are able to calculate for stoichiometric air-fuel ratio on other fuels. Methanol, E85, diesel are probably the most common that are being used with this kit. Now let's talk just quickly about part numbers. The 90067 is this entire kit that comes with the module, the sensor boss, a little bit of Velcro, the instructions, and the wiring harness. If you need to replace the air-fuel ratio sensor, maybe you're running a leaded engine or you've just used it a long time in a performance application and it's worn out, 91091 is going to be just the sensor itself. And if you're installing this kit or using this kit to tune multiple engines and you need multiple sensor bosses and plugs, 91301 is going to be your part number for these. Everything else is going to come as the kit only. So if you need a replacement harness or you need a replacement module, you will need to purchase the entire kit. Just know also, due to the nature of this sensor for tuning purposes, running in very rich conditions, performance conditions, leaded fuel potentially, there's not going to be any warranty on the air-fuel ratio sensor itself. As for the rest of the kit, it will fall under the standard 60-day limited warranty. So I think that answers the common questions that fall around the AFRM kit. It's really a great kit that you can install on any engine as a standalone air-fuel ratio monitor. So thank you for watching, and we'll see you in the next one.